Assalamualaikum. My name is Nur Balqish Nadira. So today I will show you guys on how to answer chapter 1 question. Okay, for 1A question, it asks to determine the number of subatomic particles in each of the following species. So as we can see from the table, it gives the isotope notation for titanium, barium, and arsenic, and it asks for the number of proton, neutron, and electron. So from the isotope notation of titanium, we found that the 204 is represent the number of nucleon, which means the number of nucleon is the total number of neutron and proton in the nucleus, while 81 is the number of proton, represent the number of proton. So we already know the number of proton for titanium is 81, while the number of proton for barium is 88, and the number of proton for arsenic is 33. Next, to determine the number of neutron, we need to use this formula, which is nucleon minus with proton number. So 204 minus with 81, and you will get 1, 2, 3 for the neutron. And then for barium, 137 minus with 88, and you will get 49. For arsenic, 75 minus with 33, and you will get 42. And then the number of electron. We all know that the number of electron is same as the number of proton. Hence, the number of electron for titanium is 81. But for the barium, it has a different cases because barium is a cation, which means it will donate electron. Since barium has charge of 2 plus, it means barium has donate its electron. It donates 2 electron. So the number of electron for the barium was less than proton number, which is 86. And for the arsenic is an anion. It will receive electrons. So arsenic has a charge of -3, which means it will receive 3 electrons. So the number of electrons of arsenic is higher than the number of proton, which means 36. For question 1B, analysis using mass spectrometer shows that copper consists of two natural occurring isotopes, 63 copper and 65 copper, with their isotopic masses of 62.9300 AMU and 64.9280 AMU respectively. If the ratio of the relative abundance for the two isotopes is equal to 2.235, calculate the percentage of relative abundance of each copper isotope and the average atomic mass of copper. So from the question, we get that the ratio of the two isotope is equal to 2.235, which means the relative abundance of 62 copper is equal to 2.235, while the relative abundance for 65 copper is equal to 1. So from there, we can determine the percentage abundance of 63 copper by divided the 2.235 divide with 1 plus 2.235 times with 100, and you will get 69.09%. That is the percentage abundance for the 63 copper. Next, for the percentage abundance of 65 copper, 1 will divide with 1 plus 2.235 times with 100%, and you will get the 30.92%. That is the percentage abundance of 65 copper. Next, the question asks for the average atomic mass of the copper, which means we need to use this formula, which Q is stand for the relative abundance and M is stand for the isotopic mass. The isotopic mass was given, which is the 62.93 AMU and 64.9280. So we just need to substitute the information given in the formula, and you will get the answer of the average atomic mass of copper is equal to 63.5478 AMU. This is the final answer. Next, for question 1C, it says that ascorbic acid, which is vitamin C, cures scurvy and may help prevent the common cold. It is composed of 40.92% of carbon, 4.58% of hydrogen, and 54.50% of oxygen by mass. The molar mass of ascorbic acid is 176 g per mole. Determine the empirical formula and molecular formula. So first, we need to do a table, which consists of element, mass, number of mole, ratio, and also simplest ratio. For the element, we have the carbon, hydrogen, and oxygen. And for the mass of carbon, we can get from the question, which is 40.92, which is 40.92%. And then for the hydrogen, the mass is 4.580, and for the oxygen, the mass is 54.50. Next, we need to find the number of mole for each element, which is for carbon 40.92 will divide with the mass of carbon, which is 12. So 40.92 divided by 12, and you will get 3.41 mole. And for hydrogen 4.58 divided by 1, and you will get 4.58. And then for oxygen 54.50 will divide with 16, and you will get 3.40625. And then to find the ratio, 3.41 we divide by the smallest number of mole, which is 3.40625, and you will get 1 for the ratio for carbon. And for the ratio of hydrogen, you will get 1.3446, and for oxygen you will get 1. So we need to find the simplest ratio. So we need to times with other number. Start with small number, for example 2, and then start, if you didn't get the whole number, try the next number, which is 3. So for carbon, 1 times with 3, and you will get 3. And for hydrogen, 1.3446 times with 3, and you will get 4. And the oxygen also 1 times with 3, and you will get 3. Hence the empirical formula is equal to C3H4O3. Okay, next we need to find the molecular formula, which is N in the bracket C3H4O3 is equal to the molar mass of the ascorbic acid, which is 176 g per mole. And then substitute the number of mass of each element, which is C equal to 12, H equal to 1, and O equal to 16. And then we need to find the number of N, which is 176 will divide by 88, and N is equal to 2. And then we get the molecular formula is equal to C6H8O6. Then, for the question D, a saline solution is prepared by dissolving 9 grams of sodium chloride in deionized water in a 500 ml volumetric flask, and the density of the solution is 1.18 g per ml. Calculate the molality of sodium chloride. So we need to take out the information given from the question. For example, mass of solute is equal to 9 grams, volume of solution is equal to 500 ml, and the density of solution is equal to 1.18 per gm per ml. Next, we need to write down the formula for the molality, which is equal to mole of solute divided by mass of solvent. So from the formula, we can know that we need to find the number of mole. So number of mole of sodium chloride is equal to mass of the solute, which is 9 gram, divided by the molar mass of the sodium chloride, which is 23 plus 35.5 g mole, and you will find that the number of mole of sodium chloride is equal to 0.1538 mole. So we already found the mole of solute, and then we need to find the mass of solvent. So in order to find the mass of solvent, we can use the information given, which is the density of solution, and we write down the formula of the density, which is equal to mass of solution per volume of solution, and then we substitute the information, which is the mass density is equal to 1.18, and the volume of solution is equal to 500 ml, and we can find the mass of solution is equal to 590 gram. And then we need to find the mass of solvent, which means mass of solution minus with mass of solute, and you will find the mass of solvent is equal to 581 gram, and then we need to turn it into a kg, which is 0.581 kg. And then we substitute all the information, which is the mole of solute and the mass of solvent, into the formula, and then we can find the molality is equal to 0.2647 mole per kg. Hashtag done. Okay, for the last question, it asks to find the percentage by mass of sodium chloride. So we use the formula of the percentage by mass, which is equal to mass of solute divided by mass of solution times with 100. So We've already find the mass of solid is equal to 9 gram, and the mass of the solution is equal to 590 gram, and times with 100, and we will get 1.53%. That is the final answer.